Hello and welcome to the Chapter 3 podcast on Section 3.2. So today we're going to talk about some simple chemical reactions as an introduction to the topic. So these are not the only kind of reactions that we'll talk about. In fact, there are many reactions that we're going to spend a lot of time on as part of this course. But the first two kinds that we'll talk about initially are combination and decomposition reactions. So in this table, it kind of summarizes what both of these are. A combination reaction is basically where you have two reactants or more than two reactants combined to form one product. Okay. Now a lot of times it's elements combining to form a single product, but it's not limited to elements. You can also have compounds coming together to form larger compounds. Decomposition reactions are kind of like the flip side of the coin with respect to combination reactions. So instead of a single product, like with combination, we have a single reactant which breaks down into two or more products. A lot of times these products are often smaller compounds or elements, and that's something we'll also spend some time on as well in terms of knowing what it'll actually break down into. This figure's from your book, and this kind of highlights a combination reaction that happens. This is an example of where you have pure magnesium metal combining with oxygen to burn to form magnesium oxide. So this white flaky solid is the magnesium oxide. And so what's happening here is trying to illustrate what's going on during this process. So basically, if you remember Dalton's theories, he talked about how during chemical reactions, bonds are broken and rearranged and new ones are formed. So what's happening here is the metallic bonds holding the magnesium together are broken, as well as the oxygen atoms holding the oxygen in the air together are being broken to form a combination of magnesium and oxygen, which is our ionic product, magnesium oxide. Okay, so both of these initially, in terms of charge, have no charge. But what ends up happening during this process is oxygen steals electrons away from magnesium, resulting in oxide anions, and magnesium, having lost its electrons, becomes positively charged. And what ends up happening is the opposite charge is what draws them together to form this salt, which is another way of referring to an ionic compound, which is a combination of magnesium ions and oxide ions. Okay. Now, why does this actually happen? It's because this is actually a more stable state given the conditions that happen. So what you don't see in this reaction is that we actually hold this magnesium to a burner flame, and so that the energy kind of is the driving force behind the breaking of the bonds and the formation of the new ones. But in chemical reactions, most things are driving towards achieving a more stable state, and magnesium and oxygen gas are actually more stable combined together than by themselves. There are many combustion reactions. The one thing you have to remember about combustion reactions, this is another kind of reaction, so we have combination, decomposition, and our third one that's introduced here is combustion. What you always have to remember is that oxygen from the air is one of the reactants. Okay, so if they say burned, it's implying that oxygen gas is there, and this type of thing tricks a lot of chemistry students initially because they forget that there are gases in the air that can also combine with compounds. We'll talk a little bit more about this in class, but the primary kind of combustion that we're going to concern ourselves with for right now is combustion of hydrocarbons. So if you remember the hydrocarbon stuff we introduced at the end of Chapter 2, hydrocarbons are covalent compounds that are made up of carbon and hydrogen, or carbon, hydrogen, and oxygen. Whenever you have a hydrocarbon that's being burned, the products are always CO2 and H2O if it's something that we call a complete combustion reaction. Complete combustion reactions will always give you carbon dioxide and water as products. In complete combustion reaction, you would also have some carbon monoxide, CO, as one of your products as well, but we usually won't have that happen. Okay. Now, this reaction is a little bit different than the magnesium oxygen reaction in one sense, but it also has some things in common. in the what they have in common is that bonds are being broken and new ones are being formed. But what's different about this one is that we're talking about molecular compounds, so we're talking about covalent bonds being broken and formed, which is a little different than ionic ones. So no electrons are being ripped away per se in the same kind of way that the ionic ones are, but it's similar in that sense where oxygen is basically splitting apart the propane, which is the C3H8, forming the carbon dioxide and water. So propane in the presence of oxygen is more stable when it's broken apart into carbon dioxide and water than it is to stay in this state. And again, what is it shown in these reactions is that there's a little spark to kind of initiate the beginning of this combustion reaction, and it'll continue as long as we continue to provide gas, the hydrocarbon gas, for this. And I believe that is it for now.